Hello and welcome to this brief overview of another basic concept of the F-14 Tomcat cruise workflow. This time the topic is the AN/ASN-92 inertial navigation system, and in particular the implication of operating from a carrier. The INS is a complex topic. Due to its age and the technology used, it has a few flaws and imprecisions. Examples are the precession of the AHRS at certain degrees of pitch, the accumulated error over time, and the susceptibility to odd maneuvers. Every virtual radar intercept officer has probably noticed how, when operating from a carrier, the computed magnetic variation, VC, tends to be widely different from the value of the manual magnetic variation, VM. However, by discussing with friends and teammates, I noticed how not everyone is aware of the concrete implications of this phenomenon. This video, therefore, as other from this series, aims to visualize the practical effects, hopefully making them easier to understand. What you're watching now is an example of a complete synchronization of computed magnetic variation. The initial value of VC is -13 degrees, VM is 4.9 degrees. The total delta, therefore, is about 18 degrees. The synchronization processes at a ratio of circa 10 degrees per second, but there are some caveats. To sync, the speed of the Tomcat must be uniform and it must be flying at a constant altitude. As you can see, it takes about 2 minutes to complete the synchronization. The heading push button in the compass control panel should help the process, but I had mixed results with it. More details about my test can be found in FlyingWire or in my book. Unfortunately, due to its position, I was not able to include in this video the sync indicator located in the compass control panel. During the sim process, the indicator usually moves from a side to a center position, as the difference between the initial and computed magnetic variation and the real one decreases. The two big things you may have noticed are the changes to the VDI and the BDHI. As you may remember, they are fed by different devices, but both display the symptoms of the VC, the synchronization. In case you miss them, no worries, the effect becomes much more pronounced at a faster speed. What you're watching now are the VDI and the BDHI as they sync in the top half of the screen, along pictures of the same devices once they are synchronized in the bottom half of the screen. On the left, the TAC view track of this test. The action is displayed 5 times faster. What we can immediately notice is how the F-14 is not changing heading, yet the avionics is telling a different story. And the cause is the value of the computed magnetic variation. So, what are the conclusions of this short video? In premise, the INS is important, but it requires some attention. Although there are workarounds to offset the synced VC, allowing the computed magvar to synchronize is important, and this operation can be done either post-departure or later when en route. However, if it is not done, the difference between the Tomcat's indicated heading and, for example, a target's bearing can be several degrees off. I thoroughly recommend you to go deeper into this fascinating topic of the inertial navigation system, and the first stop is the usual excellent F-14 manual written by Blur. A more practical approach can be found instead in my book, Virtual Backseaters Volume 1, and on my website, FlyingWire. Thanks for watching.